Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I'm Rossitah Binti Selamat. I'm honored to stand before you today as a representative from Politeknik Tuanku Sultanah Bahiyah. As someone deeply passionate about environmental sustainability, I have been driven to find innovation solution to address the critical issue of water pollution.
And that brings us right to our first section. We need to talk about the hidden dangers, the problems with the solutions we already have. Because honestly, to really get why this magnetic idea is so cool, you first have to understand why the old ways just aren't cutting it anymore. Okay, so think about it like this. On one hand, we've got chlorination. Yeah, it's great at killing germs, no doubt. But it can also react with stuff in the water and create these nasty byproducts that might be carcinogenic. Not great. Then on the other side, you've got natural methods like riverbank filtration. Sounds awesome, right? And it is, until it's not. These systems have a breaking point. When you get massive floods, like the monsoons in Malaysia where this study happened, the whole system can just get overwhelmed. And that's when dangerous bacteria like E. coli can sneak right through. You can see why we desperately need a better, more reliable option. So this is where things get really interesting. Let's jump into our second section, because here we're going to see how scientists are tackling this problem not with chemistry, but by using the fundamental forces of physics. It's an unconventional weapon, for sure. And that weapon is something called a low-frequency electromagnetic field, or LF-EMF for short. Now, what's really fascinating here is that it's non-ionizing. That just means it's not the kind of scary, harmful radiation you might be thinking of. Instead, it's a very specific, carefully tuned field that's designed to just mess with and deactivate microorganisms. It offers a way to purify water that's completely 100% chemical-free. And that brings us to Section 3, how this thing was actually designed. And believe me, the process was incredibly meticulous. First, the researchers used this really powerful software to simulate a full 3D model of the device. The whole goal here was to perfect the magnetic field, to make sure it was perfectly uniform all the way through the pipe. It was only after they got that simulation absolutely perfect that they even started to build the physical prototype. So what did this thing actually look like when they built it? Well, every single part was chosen for a very specific reason. The main tube is polypropylene because it's not magnetic, so it won't mess with the field. Then you've got 900 turns of copper wire. That's what actually generates the field. And here's the really crucial part. It's designed to run on solar and battery power. That makes it absolutely perfect for rural or off-grid places. You know, the very communities that need clean water the most. Okay, so the virtual model was a home run. The physical prototype is built. Now comes the moment of truth, right? For Section 4, we're going to see how this device actually held up in a real-world test, using some seriously contaminated water straight from Malaysia's Kirian River. So the very first test was pretty simple. Did the real thing work like the computer model said it would? And the answer was a huge yes. The simulation predicted a field strength of 12 millitesla, and the actual prototype measured just over 14. We're talking an error margin of only about 5%. That's just incredibly impressive, and it proves how solid their design process was from the start. All right, but now for the real test, the biological one. And this is the number that changes everything. When they ran that contaminated river water through the system, under the best possible conditions, the inactivation rate for E. coli was 100%. A perfect score. Absolutely amazing. So the test was a massive success. But what does all of this really mean for the bigger picture? Let's zoom out in our final section and really think about the global impact this kind of technology could have. What it all boils down to is that we're looking at a solution that just, well, it ticks all the right boxes. It's chemical-free, so you don't have to worry about creating dangerous byproducts. It's sustainable, powered by the sun, making it perfect for remote areas. It's precisely engineered, and this is a big one. It has the potential to be scaled up for huge industrial-level water systems. This isn't just some neat lab experiment. It's a potential game-changer for water safety all over the world. And that leaves us with one last, really fascinating thought to chew on. For decades, our go-to answer for dirty water has been chemistry. But what this research does is it adds a powerful new tool to our arsenal, one that's based on the fundamental forces of physics. It's clean, it's elegant, and it's incredibly effective. And as we look to the future, it really makes you wonder, could the solution to one of our oldest and biggest problems be magnetic?